Okay, hi. I was not about to make such kind of videos because I was very much occupied these days, but seeing the growth of Deepseeker, I don't know, I should be happy. As a technical person, I am happy because of open words getting so prominent in this industry. I don't know about the political thing or the other economics thing. Not my field to be worried about. Yeah, but I see a lot of people getting confused about these models and how does open weights work and all these things. So obviously, I'm not going to explain it all, but the accurate amount of information that I've already told to like 10 people, and I don't want to repeat. So I'll be just using these videos as always. So most people think that these AI models have some kind of database from where they extract information and then they formulate it in the language that we understand, and then they give it to us. That is how it works, but it does not. I'm not going into the transformer architecture, but basically they don't have any database of information. Obviously, I'm not going into the training part and reinforcement learning with human feedback and fine tuning and all that stuff and how that's important. But from the consumer point of view, the things that we need to take care of is the weight size, how much is the weight, how much parameters do they have, and the quantization in some way or other. So the amount of parameters that a model has is everything that you need to be concerned about, and all the knowledge that the model has is within those parameters. It doesn't need anything external from those parameter size. One parameter can be equivalent to 1 byte of information, because a parameter is basically a weight, and a weight is a number, floating point number, and 1 byte is enough to represent that. So 1 billion parameter model would be of size of 1 billion bytes converted into GB and TB and whatever you want to do. So 1 billion parameters is equal to 1 billion bytes. That is all the knowledge and all the database that it needs, all the storage that it needs to work upon. Weights is everything that you need. 1 billion parameter model will need just 1 billion bytes of storage. Obviously it will need some bytes more here and there, some GB more to set up, to environment, to instruction, for all that stuff, but the main knowledge, the main database is just of 1 billion bytes. So you can understand, like all of the internet, everything is compressed to 1 billion bytes. That's all. There's nothing more that is required. It doesn't need some more data. So it can work on your local device as well. If you have that much amount of RAM, this can be another analogy that you can use. So the billion of bytes it has is the amount of billion of bytes of RAM you need. So if it is like 8 billion parameter model, then you need 8 billion bytes of RAM in your laptop, or more, obviously a bit more, let's say 2 or let's say 20% more for processing and other cost of storage. There is this RAG system, retrieval augmented generation, in which it goes to internet, take information from there and put it in the context and then generate. But that doesn't mean that it needs a database. It can work independently also. In this RAG system, it basically does this thing where it uses the same billion of parameters of model that it has, but it also gets some extra information using some ways of searching and indexing from the internet. It gets the information and put in the context, and then it gives the output. So it's not like it is fine tuning the model. So RAG is a method that needs database, or that needs internet, but that's not necessary, and that's not how the model is supposed to work. The training part is computationally heavy. It is chaotic, done with a lot of money and all. I don't go into that. You cannot call it compression of knowledge, but in some way it's compression of knowledge. But the inference part that we do on our PC from these weights, that is not very chaotic. It's very easy. It is very much compute efficient. So you just need a good amount of hardware to get information out of these weights. To put information and knowledge into these weights is the hard part, but to get knowledge and information out of these weights is the easy part. Well, you can use some kind of analogy or anthropomorphization thing, as humans often do, to understand things. So you can think of it in the context of a doctor thing. How does the training of a doctor works, and how does finally he treats patients? So as it always goes, the better the doctor is, the more amount of training it has done. When I say it, please make it he or she based on the whatever kind of doctor you want to imagine. So the better the doctor is, the better amount of training it has done. And when I say training, it means going to a better school, having more time of experience with more patients. So the training part is the hard part. The part where a person goes to a school and studies about biology, or where he goes to a hospital and treats a lot of patients and gathers experiences, that's the hard part. But you as a consumer going to the doctor and asking about the information, or asking about how to get yourself with your biology fixed, diagnosis, treatment, that is not the hard part from your end. So that's very less compute heavy, that's very compute efficient. But for the doctor, it is very compute heavy. It has to go like, I guess, 10 years of training to be able to do so. So that is similar kind of case with respect to inference. All the knowledge based on which the doctor is giving the answer or giving the diagnosis or giving the treatment is just based on his mind. It's just that. It is not like he's having a database of internet or book that he's referring to and then he's giving to answer. He can do that. That's the RAG system, when a doctor studies internet and gives you the answer. But again, mostly when doctor sees and diagnoses, it's just based on his intuition and based on his understanding of the world. That's the best information I can do. So all you need is the amount or the billion of bytes that the parameter has. That's all you need. About quantization, so quantization is like compression of compression. So as I said, this training is like compression of knowledge, and when we quantize, then we quantize this, then we compress this knowledge base or bytes into some more format. So the more quantized a model is, the lesser better it will be, because how much can you compress knowledge in a way. So that's all. That's nothing more you need to know, and I'm very happy to see all this revolution and all. The DeepSeek R1 is really getting good, but I was already having a hint of it, especially from the Quen models. Quens were doing very good. I even have Quen 2.5 coded from very long ago. So seeing DeepSeek R1 also being able to do text time compute, that is called COT, chain of thought, and thinking is what we call, that's really good to see. And everything kind of applies in the same way. The hard work is not necessarily the way. Like, you don't need to study a lot to become a good doctor. You can be more efficient, like the smart work. So as far as I can study about the DeepSeek R1, I have not studied much. I have not got enough time. I have just like 2-3 hours of study about this. I am happy to see that they have used some kind of smart ways that people were not really using earlier, the OpenAI and all the stuff. They have used extensive amount of RL, reinforcement learning. That is also very much good with respect to giving better results. So yeah, overall it's a good model, it's a good weight, and it is free, so that's even more powerful. So like, you have got a very good doctor who is working for free. That's really nice to see. I'm very happy about this DeepSeek R1, not because of the technical thing only, obviously that's the thing that I'm making me happy, but also because of the things that it will bring along with it, the market effect and all the stuff. Someone is doing so good, so that the competition will also do good, and they will try to reduce the market price and all. That ChatGPT has a lot, like basically what Geo did for India. I don't know how many are aware of that. So that's really good to see. And also good thing to see is that people who were not thought to be working in this way, like China, doing something like this, like a philanthropy thing, that's something that they're also doing. So that's really nice to see. And overall, just the starting of the year, and we already got such a great model. I'm happy that in future there will be some more things. Like, this is the worst it can get. It will get even better. And yeah, overall very happy about this thing. Let's see how this goes, and I hope the safety thing goes along with it equivalently. The capability thing doesn't scale and the safety doesn't plummet, because then it can be a very chaotic thing. It's like a markdown moment for sure, as far as I can see, that such great level of models are becoming open weight. So that's a great moment for in the time of AI, and I hope it is equivalently important in the timeline of AI safety, because if not, then things are going to be very hectic and bad for everyone. So that's all for this video, just a short video. I hope you got enough information. If you need something more, comment down or something. I'll try to give more information as far as I know. And yeah, just happy to see this. Bye, have a good day. Okay, now finally checking the audio with this external Maple mic. पता नहीं क्या बोलते इसको. And yeah, going to start the video. Final check. Bye.